Hello students. Students, in this video we will learn about the 3 points: sign conventions for spherical lenses, second lens formula, and third magnification by lens, spherical lens. So let's consider about first point, sign conventions for spherical lenses. You know, let this is the lens, this is the convex lens, and let this is the principal axis of this convex lens, and here optical center is there inside the convex lens, and in the left hand side of this lens here f1 is there. This f1 is called the first principal focus of the convex lens. Okay, and in the same distance of this distance here 2f1 is there. Okay, now and in the right hand side of the lens here f2 is there. This is the second principal focus of this convex lens, and in the same distance of this distance here 2f2 is taken. Okay, now the distance of f1 from optical center is denoted by f1, and this small f1, and this distance is called the first focal length of the convex lens. Okay, and let this is the line, and in the right hand side this is the second principal focus of the convex lens, and the distance of the second principal focus from the optical center is denoted by f2, that one distance. Okay, and this distance is called the second focal length of convex lens. Okay, here you have to remember here for thin lens f1 is taken equal f2, means it is assumed that the first focal length is equal to the second focal length for thin lens, for thin convex lens, and it is taken as equal to f. So now this will be focal length for convex lens. Now what will be the sign of the focal length of convex lens? And now before that we will discuss about the concave lens. Okay, so let this is concave lens, and this is the principal axis of the concave lens, and you know, in the case of concave lens first principal focus is in the right hand side of the concave lens, but in the convex lens first principal focus is in the left hand side, and here for concave lens 2f1 is there, and in the left hand side of the concave lens here f2 is there, second principal focus of the concave lens, but in the case of convex lens second principal focus is in the right hand side of the lens, and in the same distance as that distance here 2f2 is taken. You have to remember this point. Okay, now for this distance for the concave lens, this is denoted by f2, and this is called the second focal length, and first focal length for concave lens will be f1. Okay, for thin concave lens here f1 is assumed equal to f2, and let it is equal f. So now this is the focal length for concave lens. Okay, here you have to remember this is for thin lens, and this is also for thin convex lens. Okay, now what will be the sign of focal length of concave lens, and what will be the sign of focal length of convex lens? So we will discuss about the sign conventions. Okay, now for this we will discuss about other diagram. So let this is the convex lens, and this is the principal focus of convex lens. This, and this is the optical center, and this is f1, and here 2f1, and here f2 is there, and here 2f2 is there for convex lens. Okay. Now if an object is placed at this point beyond the 2f1 AB object, so light ray originates from the top of this object. This light parallel to the principal axis of the lens, then the light ray, after passing through the lens, it will go through the second principal focus of the lens. Okay. Now this is what is the direction of incident ray. The direction of incident ray for this lens is left hand side to right hand side, means this is the direction of incident ray. Okay. Now here we have to remember that first point for the sign convention, all the distances are measured from the optical center of the lens for convex lens and for concave lens also. So all the distances are measured from the optical center of the lens. Okay, this is the first point. And second point, along the direction of incident ray, if we are measuring the distance in the same direction of the incident ray, okay, because we are measuring the distance from optical center, so what will be the distance of the same direction of incident ray? The distances in the right hand side of the lenses will be measured in the same direction of the incident ray. It means if distances are measured in the right hand side of the lens, then distance is measured from this, so we will measure along this direction 1 centimeter, 2 centimeter, 3 centimeter. So we are measuring from this distance, from this point. So the right hand side of the lens, the distances will be same direction of the direction of incident ray. Okay, and if we are measuring the distances along this direction, because to measure the distances in the left hand side of the lens, we are going from point O to left hand side, and we are going along this direction, but the direction of incident is left to right, and we are going from right to left, so the distances will be negative in the left hand side. All the distances are measuring in the left hand side of the lens will be negative, means these will be negative, and these distances in the right hand side will be positive, because these distances are measuring in the same direction of incident. The direction of incident ray is along this direction, and the distance measuring direction is along this is also along this direction, so these are in the same direction. That's why the distance from O in the right hand side will be positive. And because for the distances in the left hand side, we are going right to left, but the direction of incident is left to right, that is opposite. That's why the distances from optical center in the left hand side are taken as negative sign. Okay, this is the sign convention. And you know, this is the height of the object, and if light ray travels towards the optical center after passing through the lens, the image will be here. So this is object and this is image, A dash B dash. This is the height of the object and this is the upwards with respect to the principal axis. This is principal axis and this height is upward with respect to the principal axis, but the height of image is downward with respect to the principal axis. So all the heights upward, all the heights are measured upward with respect to the principal axis will be positive, will be in positive. So AB will be positive and this is in the downward direction with respect to principal axis. That's why the height of image will be negative. Understood? And in the case of this concave lens, here will be in the same, because the distances will be measured from optical center, and if the direction of incident ray is along this direction, left to right. Okay, now, and the distances are measuring from optical center. That's why if distances are measuring along this direction, the direction of measuring distance and the direction of incident ray is same direction. That's why the distances are measured in the right hand side of the concave lens will be positive. Okay, and if here f2 is there, if we have to measure the distance of f2, so to find this distance we will have to go from this point from point O in the left hand side. So we are going along this direction, but the direction of incident ray is along this direction. These directions are opposite to each other. That's why when directions are opposite, means the direction of this measuring distance is opposite to the incident ray, then this will be negative. So these are for both lanes same, negative in the left hand side. Here the distance is also taken in the taken negative in the left hand side for concave and convex. And so this is the sign convention. Second, so first is all the distances are measured from optical centers, and the if the distances are measured in the same direction of the direction of incident ray, then these distances are taken as positive, and if the distances are measured opposite to the incident ray, then the distances are taken as negative. Okay, this is. And height, third point, height. If the height is measured upward with respect to the principal axis, then this will be taken as positive, and if the height is measured in the downward direction with respect to principal axis in the case of both lenses, then the height will be taken as negative. Okay, 3 points are there.